Okay, so chapter 9, by its name itself, I think that's boleh guess good. Chapter ni pasal quantization of light. So we discuss about light, but now we treat light tu as a particle. So it behaves like a particle lah, quantized. Okay, so in this chapter, you guys will learn about two things. First is about Planck quantum theory. Okay, you have a formula on how to calculate the energy of light. And then you have a photoelectric effect experiment. Okay, where we discuss about this particular equation, a very important equation. For the first subtopic, we discuss about you need to be able to state Planck. What is Planck? Planck and comparison between Planck and classical, and then able to calculate using this equation, it's the photon energy equation. Okay, so previously classical theories they basically use black body radiation punya theory. Okay, black body. What does it mean by black body? It is actually an ideal system that absorbs all radiation incident on it. Okay, so any radiation incident on the black body itself, dia akan absorbs. Okay, then the electromagnetic radiation emitted by the black body is called the black body radiation. So the black body radiation ni basically the plot in a graph of intensity against wavelength. So basically you get a spectrum lah, many different wavelength, right? Then when they plot, they get these actual values over here. Okay. Yang ni adalah yang nilai sebenar lah, nilai experimental. So classical theory dia ada dua. One is about Wayne's theory. Okay, Wayne's theory ni dia able to predict dia punya data ni up until a certain point saja, which is dekat lambda yang rendah lah, yang dekat sini. Dan after a certain point, dia punya prediction tu dah tak valid. Nilai dia lari daripada eksperimen. Okay, and there's another theory which is Rayleigh-Jeans theory. Okay, that one dia predict yang dekat longer wavelength, kat hujung sini. Tapi dekat depan ni, dia tak boleh nak predict behavior dia macam ni. Okay. One of the main reason because they basically assume that energy is equal to KBT. KB here is stand for Boltzmann constant. T here is temperature. So basically they assume as the temperature increase, energy is increased. That is not true, right? So only Planck that actually can predict the total for all the wavelengths, they boleh predict Planck. Okay, ini saya dah cerita. Tadi dia kata the main reason kenapa dua teori ni tak boleh nak predict, because basically they assume that EM radiation does not depends on its frequency and wavelength, which is not true lah. And the energy of EM radiation is continuous. Okay, so classical theory mainly dia banyak assume based on observation and logical thinking. Maksudnya dia fikir benda tu logik, dia assume. So at that time memang nampak logik lah. If you look at the ray ataupun light kan, dia nampak seperti ray like that. Okay, kita treat dia sebagai ray. So basically kita anggap dia sebagai continuous. But that one is not true. Actually electromagnetic radiation emitted by black body tu adalah in discrete form. Okay, discrete ni macam sekutul-sekutul. Okay, packets of energy one by one lah. So basically macam particle. Kalau kamu ada 10 ketul lah. Kau kena bayangkan lah cahaya tu kita kena treat dia sebagai ketul-ketulan. Each packet is called quantum of energy. This means that the energy of EM radiation is quantized. So the main word here is quantized. The energy size of radiation depends on its frequency. Okay, ni ada key criteria lah. Energy tu tak depends on the temperature, but it depends on frequency. And because it depends on frequency, it also depends on the lambda. Okay, so far kamu boleh faham ke tidak? Can you guys follow me?
Faham, sir.
Faham, sir. The main thing about classical theory, mostly dia predict tu based on observation, apa yang logik. Tapi yang sebenar-benar yang berlaku is a little bit macam tak terfikir lah at that time. Okay, so Planck dia creates an equation. So E ni dia kata directly proportional to the frequency. Energy tu directly proportional to frequency lah. And then dia buat equation yang ada Planck constant H. Okay. So H ni is a value which is 6.63 times 10 negative 34. Okay, the unit will be joule second. So you can expect, okay, because this one is joule second, so it is in SI unit, right? Joule second ni SI unit. So you expect if you want to use this formula, you have to use SI unit. energy need to be in joule, frequency need to be in hertz. Biasanya energy ni lah. So energy ni, okay, kalau kita cakap pasal photons, we are talking about very small particle of photons. Normally the energy for that particular photon is very small. Normally to the power of negative 20, negative 21 or negative 19. So because of that, they create another unit. This unit is what we call electron volts. Okay, the symbol for this unit is EV. Okay, and then 1 EV is equivalent to 1.6 times 10 negative 19. So if you calculate in terms of EV, you will see that your values normally maybe dalam apa ni 0.2, 0.23 ataupun 1.3, 2.4. So nombor tu lagi senang nak tulis. Okay, so that's why sometimes they ask you to write final answer in terms of electron volts, or maybe they give you question in terms of electron volts. But remember, if you want to use this formula, you have to use SI unit. Energy need to be in joule. Okay, and then from this equation actually comes from the basics of velocity. V is equals to S over T. Now if you're talking about wave, so S becomes lambda, one complete cycle, right? Then period, time becomes period. So I can bring time ni naik atas, so dia jadi F. Okay, if you're talking about lights, V ni, velocity of light, is actually C. That's why we have this formula. C equals to lambda F. Okay, C is the speed of light. Kau tahu tak speed of light berapa nilai dia? Speed of light. What's the value for speed of light? Okay, it will be 3 times 10 to the power of 8 ms minus 1. I think you guys dah belajar kot kat school dulu. C tu. So basically, you have a few constant. Okay, C dengan H, up until now C dengan H lah. And then cara nak tukar unit is this one. Okay, and then 1905, Einstein and Standard Planck's ideas by proposing that EM radiation is actually quantized. It consists of particle like packets of energy called photons. Okay, so Einstein actually describe yang energy EM tu quantized, and then dia cakap benda tu adalah photon. So basically kamu boleh kira lah nilai energy by total photon. Basically you just have to multiply with numbers of photon there. And okay, so what is photon? Photon is actually defined as particle with zero mass consisting of a quantum electromagnetic radiation. Okay, dia tak ada mass and then the massless lah. And then quantum radiation where its energy is concentrated. Jadi energy je. A photon may also be regarded as a unit of energy equal to HF. Photons travel at the speed of light in a vacuum. Okay, they are required to explain the photoelectric effect and other phenomena that require light to have particle property. So basically, because the photon is quantized, so it shows the behavior of a particle. Okay, remember, photon is quantized. So bayangkan cahaya itu sebenarnya adalah seketul-seketul. Okay, the difference. Okay, EM waves, basically this one is more like a classical theory, and this one is more like Planck theory. So classical says that energy of EM depends on the intensity of the wave. Okay, so maksudnya dia anggap kalau lagi terang cahaya tu, dia anggap energi dia lagi besar, which is at that time it's quite logical lah. Lagi cerah, lagi tinggi energy. But that one is not true. Okay, they also assume that energy is directly proportional with temperature. That one is not true as well. So actually energy directly proportional with the frequency ataupun inversely proportional to the lambda. So shorter wavelength, higher energy, longer wavelength, lower energy. Basically, it depends on the color. So different wavelength shows a different color. So you can see that as a different colors give a different energy. And then it's assumed that energy is continuously and spread out throughout the medium as shown in figure 9.2. So basically, they assume ray tu kan, cahaya tu adalah energy yang spread out macam beam, beam of energy. Tapi sebenarnya energy ni dia datang seketul-seketul, photon. Okay? And in fact, later you will learn that photon ni dia akan interact with one electron bila kita buat photoelectric effects. So satu photon, satu electron, things like that. Okay, before we go into 9.2, do you have any question so far? Or maybe boleh proceed? Can we proceed?
Proceed, sir.
Okay, so 9.1 tu dia punya equation yang kamu kena kira is basically just a lambda. Kalau ikut 9.1 lah, E sama dengan HF ataupun E sama dengan HC over lambda. Yang dekat 9.2 baru kamu ada another equation. So in 9.2, you need to be able to define photoelectric effect, explain the phenomena of photoelectric effect by sketching the diagram of the photoelectric effect experimental setup, define and determine threshold frequency, work function and stopping potential, analyze by using graph and equations the observation of photoelectric effect experiment in terms of dependence of kinetic energy. Okay, ini semua benda-benda ni lah yang baca. Okay, photoelectric experiment. Ni kan, yang kedua ni kan, explain the phenomena photoelectric effect by sketching the diagram of the photoelectric effect experimental setup. So, photoelectric experiment. Okay, eksperimen ni dia saya akan tunjuk gambar yang dah lengkap, tapi saya just nak tunjuk benda ni nampak, circuit dia tu nampak macam-macam kan, tapi sebenarnya dia simple. Okay, asasnya kamu kena ada metal plate that we call as a cathode. Ini yang akan terima cahaya. Okay, so we call this one as cathode. Basically the light will be incident on this parts cathode. Okay, ini adalah metal and then ini adalah anode. Okay, so the lights will be reflected on that particular surface, metal surface tu. Okay. Walaupun saya bikin macam ray, tapi kamu anggap dia sebagai photons lah, sekutul-sekutul. So bila dia incident on the metal plate tu, dia akan produce electron. So metal plate, inside metal, kamu bayangkan ni metal surface Kalau metal actually consists of free electrons. Dalamnya ada banyak free electrons. Okay? So apa yang berlaku bila kamu ada photons incident on the surface, kalau energy of the photon cukup kuat, dia akan excite electron ni. Okay? So basically this metal dia akan ada energy yang whole electrons tu. Jadi saya akan explain more on this. Okay? Kalau incident light ni dia interact dengan elektron, energi dia lagi besar daripada W0 tu, elektron ni akan excite and then dia akan ejected, dia akan keluar. Itu dia punya idea. Okay, so elektron yang keluar tu basically dia akan keluar daripada situ and then dia akan bergerak secara tak ada rawan, dia akan terpantul lah, dia akan terus bergerak. Okay, so kalau saya nak dia bergerak kepada anode straight away, saya tak nak dia pergi tempat lain, I just want them to go to anode. Apa yang saya kena buat, saya kena apply delta V, which is basically saya ada potential difference lah. Kalau potential difference under potential difference tu dia akan effect, dia akan kasi force dekat elektron tu, dia akan pergi ke satu direction lah, which is the other side. So basically saya will connect this one to a circuit, to a complete circuit. Oopsie. Okay, tak boleh buat cakap. Okay, sebab saya nak elektron tu daripada kiri tu pergi ke kanan, so basically saya kena letak negative terminal over there. Okay, sebab ada dry cell, ada battery, ada power supply, barulah ada potential difference across here. Okay, so elektron tu akan pergi to the other side. Okay, kalau saya biarkan saya punya cathode dengan anode tu dekat air, normal air, so dia akan interact dengan partikel yang kita tak nampak. Dekat air tu ada partikel kan, so dia akan berlanggar-langgar lah. So again, dia akan lose lots of energy, so dia macam eksperimen tu tak valid. So dia lah buat eksperimen ni dekat dalam vacuum. So ini dia punya vacuum space. Okay, sebab tu dia tak nak elektron tu interact dengan benda lain. Okay, so now dia nak buat eksperimen, nak tengok kalau potential tu saya ubah, adakah current saya akan bertambah. So itu dia punya idea. So basically apa yang dia kena buat, kalau saya nak ubah saya punya potential, so basically I have to put a resistor. Boleh laras variable resistor lah kat sini. And then because I want to measure current and voltage, so kalau nak measure current, I have to put ammeter over here. Okay. And if I want to measure current, sorry, this one is current, right? If I want to measure voltage, saya kena ada voltage lah, voltmeter. Voltmeter dia punya kedudukan mesti parallel to the benda yang kita nak ukur. Kalau yang ammeter dia kena series. So basically this is the first part, part A. Okay. Ini setup untuk the first part. So basically dia nak measure kalau saya naikkan voltage, apa yang berlaku dekat current. Okay. And when they try to do the experiment, they found out that so I here is photoelectric current. Photoelectric current. Definition for photoelectric current is basically current produced by the emission of electron tu. Maksudnya kalau ada emission of electron, baru ada current tu. Kalau tak kan circuit ni terputus kan kalau tak ada elektron. So bila circuit ni bersambung, barulah ada current kat sini. So they found out when they increase the voltage, initially kamu punya current ni naik. Okay. Mainly because elektron ni bila voltage ni tinggi, dia akan pergi ke sini lagi laju. Okay. Now you know that I is equals to dq over dt. Means that if I have a larger change of charge, that means my current will be increasing. The magnitude of current will be increasing. But then when they try to increase furthermore, and then it reach a threshold. Okay, we call this one as IM, maximum current produced by the photoelectric experiment. Okay, kenapa dia dah sampai limit? Because numbers of photon. Okay, numbers of photon coming in actually related dengan intensity. Kalau kamu pakai, light source yang sama, kamu tak ubah intensity maksudnya photon yang datang tu contohnya 10. So 10 photon ni dia akan interact dengan 10 elektron. Okay. So dalam masa seminit maybe 10 elektron dia keluar. Itu maksudnya. So basically you have a limit. Okay, limit tu ada threshold lah, bilangan photon yang datang. Kalau kamu naikkan intensity, then you will have a higher photoelectric current. Itu baru kamu ada dapat beza. Sebab apa? Bilangan photon tu makin bertambah. Okay, so faham tidak?
Faham, sir.
Okay, the next part actually what they did is they try to reverse the punya polarity of this one. Okay, yang ni yang part A jadi kita pergi balik apa tu. Yang ni kita dah bincang tadi Emission of electron from the surface of metal when the EM light of higher frequency side surface. Tadi saya dah lukis kat atas ni kecil. Oops. Okay, yang ni yang part A. Sama macam saya lukis tadi, cuma gambar ni cantik sikit lah. Nanti basically it's the same thing. Okay, sebab kita dah ada graf yang separuh tu. Okay, part B pula, dia basically terbalikkan power supply ni. Okay. So kenapa dia terbalikkan power supply? Kita bagi balik gambar ni So basically dia padam, dia terbalikkan. So kalau kamu terbalikkan, basically kamu create a force in that direction. Opposite direction lah, daripada pergerakan elektron tu. So basically, dia akan mewujudkan satu macam friction untuk elektron. Kamu bayangkanlah friction tu ataupun force in opposite direction lah, kamu bayangkan. So elektron tengah jalan ke sana, ada force yang tolak dia ke sana. So kalau force tu tak kuat, elektron ni akan slow down. Tapi dia akan sampai juga. Jadi kalau force tu makin kuat, elektron ni makin slow lah. Makin slow. And eventually, one point, elektron ni dah tak sampai. Bila elektron tak sampai, circuit ni terputus, is an incomplete circuit. Bacaan current straight away become zero. Okay. So, apa yang berlaku ni, tadi, in terms of graph, sebenarnya kita cerita pasal the negative part. Masih lagi current, okay. Ini masih lagi voltage. So basically, apa yang berlaku, kita cerita pasal belakang ni. So, bila elektron makin slow, so bilangan quantity current tu makin kurang, and eventually dia stop. Bila dia stop tu, potential yang diguna untuk stop tu dipanggil stopping potential. Okay, the value will be negative sebab dia belah kamu terbalikkan tadi kan, so dia dianggap sebagai negatif lah this part. Kalau kamu combine dengan first graph tadi, dia akan dapat a graph that looks something like this. Okay. And stopping potential ni, dia depends on the material of the cathode ni. Metal ni punya material. Different material will give you a different VS. Okay, and then it also depends dengan cahaya yang datang ni, energy yang datang tu. So, ada banyak faktor yang main peranan untuk ni. Okay. So far, kamu faham ke tak pasal ni?
Boleh, sir.
Boleh, okay. That one is about theoretical part lah. So, dulu dia ada lah, kadang-kadang suruh kamu lukis, explain apa yang berlaku. Okay, tapi kalau kebanyakan markah, dia datang daripada equation tu sendiri. Okay, ni graph yang tadi saya dah tunjuk. Kebanyakan markah sebenarnya datang daripada Einstein equation. So, ramai orang anggap Einstein tu dapat award based on E equals to mc squared. Tapi sebenarnya yang equation yang paling penting is this one. Lagi saya tunjuk equation penting tu. Okay, so yang blue ni adalah photon, incident light. Okay, yang purple tu basically adalah kamu punya metal. Okay, and then kamu akan ada elektron kalau dia keluar, maksudnya dia ada kinetic energy. Okay, cara paling senang nak tengok kamu nak bayangkan yes, tak boleh hijau. Okay, energy incident light tu is actually equals to E. Okay, energy ni adalah energy yang Planck cerita tadi tu, energy of a photon. E sama dengan hc over lambda ataupun E sama dengan hf. E is directly proportional to the frequency, hc over lambda. Energy of a photon. Seketul photon tu berapa energy dia? It depends dengan lambda ataupun frekuensi. Okay, and then at the same time, dekat dalam metal ni, dia ada energy yang pegang all the electron. Okay, kita panggil ni sebagai work function. Work function ni, dia punya equation tu kira sama dengan energy yang E tadi tu. So, W0 sama dengan HF sama dengan HC over lambda. So, bezanya, instead of F, biasa dia ada not. Okay. So, basically F0 and lambda not is actually represent frequency and lambda threshold for the metal plate atau metal surface tu. Okay. So, the values of frequency and lambda depends on the type of metal. So, different material will give you a different F and different lambda. Tapi cara kira dia sama je. Masuk je juga dalam equation yang sama. Okay, katakanlah energi yang datang tu, let's say, is 10 joule. Okay. Energy required untuk atasi elektron tu kena pegang kat bawah ni, maybe 4 joule. Ni dah W0 lah. So, kamu rasa kinetic energy dia berapa?
6.
6 kan?
6.
Very good. So, basically, you left with 6 joule. So, basically, you apply conservation of energy. Energy tu tak terhapus, dia just transfer je. So, energy nak jadi energy apa? Dia jadi kinetic energy. Okay, kinetic energy ni paling obvious is dia punya kelajuan lah. So, you can relate with half mv squared. The bigger the joule energy there, maksudnya dia lagi laju. Bila dia bergerak tu, laju. Okay. And then this one, sebenarnya dia sama juga dengan, saya tengah tunggu screen saya load. Ya, half mv squared tu actually equals to EVS. E itu stand for electron, E sama dengan 1.6 times 10 negative 19 tu. Yang VS is the stopping potential. So dia ada dua term ya. E itu satu term, VS itu satu term. VS itu the voltage lah, and SI unit is volt. Sepadan ini. So basically, Einstein equation state that E incident light punya energy equals to W0 work function of the metal plus kinetic energy maximum. Okay. So dia kata itu adalah maximum kinetic energy because that one is, we assume that one is maximum lah. Maybe dia less ke apa ke, tak. Kita just cerita pasal maximum. Kalau all the energy transferred pergi ke sana. So dia jadi macam tadi lah, 10, 6, 4. So 10 tu dekat sini, 6 tu kat sini, 4 tu kat sini. Faham ke tidak?
Faham, sir. Faham,
Okay.
sir.
Again, I can substitute E tu, saya boleh tulis dia sebagai H, C over lambda, ataupun saya boleh tulis dia sebagai HF. Yang ni jadi HC over lambda naught. Dan Kmax tu saya boleh tulis dia sebagai half mv square, ataupun saya boleh tulis dia sebagai EBS. It depends on the given information. Kalau dia kasih frekuensi, pakailah HF. Okay? Tak kisahlah, mana-mana pun boleh. Tapi yang main thing is this three. Okay? Kalau saya nak tukar ikut warna yang atas tu, dan dia akan jadi macam ni lah. Like E tu, dia warna biru tu. And then, ini adalah Kmax. And this one is actually W naught. Okay, and then you have F naught dengan lambda naught punya definition. Kamu boleh tahulah. F naught is the minimum frequency required to eject electron. Okay, kalau lambda naught, the maximum wavelength required to eject electron. Dia punya definition yang full tu ada kat nota, nanti kita check balik. Required, okay. Okay. Okay, ada soalan tak? Kalau tadi kita cuba buat soalan. Boleh tak kita cuba buat ni? Okay, ini soalan ni daripada tutorial ya, question number 7A. Okay, cuba baca. A photon has energy of 3.2 electron volt. Calculate the frequency, wavelength, and energy in joule of the photon. Okay, so 3.2 electron volts tu dia punya apa?
E?
E kan? E besar. Okay, so this one is the energy. Calculate the frequency. They ask you to find F, lambda, and E in joule. So E yang diberi ni dalam electron volts. So the first thing first, you have to convert. Basically, if you want to find frequency and lambda, you can use E sama dengan HF ataupun E sama dengan HC over lambda. You can use these two formulas lah. But if you want to use these two formulas, you have to make sure your E is in joule, dalam joule lah. So first thing first, you have to convert to joule. Okay. From EV, if you want to convert to joule, you have to multiply with 1.6 times 10 negative 19, because 1 EV is equal to 1.6 times 10 negative 19 joule. And if you do that, you get 3.2 times 1.6. You should get 5.12 times 10 negative 19. Okay, so you can always double check. Joule ni, make sure the unit will be around this region. Negative 19, negative 20, negative 21. If you get a positive 20, most likely calculation kamu salah. Maybe kamu terbahagi instead of darab. So that one is one of the key things lah. You just need to be aware. Okay, if I want to calculate F, then my F is equal to E divided by H. H tadi adalah 6.63 times 10 negative 34. Pada ini pula, lambda sama dengan 6.63 times 10 negative 34. C adalah 3 times 10 to the power of 8. E dia adalah 5.12. E tadi yang sama juga. Okay. Alternatively, you can relate F tu dengan lambda, boleh juga, tak ada masalah. Saya just kira balik. Okay, I got 7.72 times 10 to the power of 14. Okay, unit dia apa? Frequency. Hertz kan? Okay, this one I got Hertz. Yang ni saya dapat 3 point. Okay, kita beli.
Go to formula.
Nice 3.88. Sama tak?
Sama.
Okay, the unit will be in meter. Ini soalan nombor 7. Jawapan kalau kamu compare dengan jawapan 388 di convert kepada apa tu, milimeter, sama je lah, benda yang sama. Cuma jawapan tu sepatutnya
Sir nak tanya,
dalam Jun. Apa?
yang HC tu nilai dia constant
H tu
Okay.
nilai dia adalah 6.63 times 10 negative 34 joule second. Nilai dia memang macam ni lah. Yang C pun sama, 3 times 10 to the power of 8. Yang C tu speed of light. Yang H tu adalah Planck constant. Okay.
Okay, sir.
Okay, soalan B tu dia kata find the energy of the photon in a beam whose wavelength is 500 nanometer. So B dia kata kalau lambda adalah 500 nanometer, dia ask you to calculate dia punya energy. So E sama dengan HC over lambda, sama lah tadi, 6.63 times 10 negative 34. C is 3 times 10 to the power of 8. Lambda is 500 times 10 negative 9. So here I got 3.98 joule. So everything in SI unit, so final answer in SI unit. Okay, next question. Question number 9. Question number 9 is interesting. When a cesium metal is incident with light having a wavelength of 500 nanometer, the electrons emitted has maximum kinetic energy of 0.5 electron volt. Okay, so dia kasih few values, 500 dengan 0.5 eV. Okay, if you get this kind of question, kamu tahu yang dia sekarang ni cerita pasal photoelectric punya effects. Okay, sebab dia ada incident light, lepas tu ada emitted electrons. Okay, so the first thing that you have to do, kamu draw a line, okay, to indicate metal tu punya surface, and then you draw an electron. Seketul cukup. And then kamu draw incident light. Okay, and then kamu draw ejected electron punya path. Ejected electron tu kalau ada ejected electron lah, kalau tak ada, tak ada. Okay, before we go further, I just want to go back over here and then I want to point out something. Okay, tadi kita cerita kalau ini 10, ini 6, ini 4 kan, ingat tak? Macam mana kalau ini 6, ini 6? Ini jadi berapa? Di sini. 6, 6.
Kosong.
Jadi kosong kan? So kalau kinetic energy 0, sebenarnya dia adalah stationary. Dia keluar, ejected tu masih lagi ejected, tapi dia just duduk diam kat situ. Okay, so yang ni takkan ada lah. So elektron keluar, dia duduk diam je. Okay, so maybe I can write over here. Okay, if kalau E tu lagi besar daripada W0, then kamu akan ada elektron with K. Okay, elektron tu ejected and then ada K. Kalau E tu exactly the same with W0, then kamu akan ada elektron tapi stationary. Dia duduk je kat atas surface tu, dia duduk kat situ. Okay, kalau dia less, kamu rasa apa berlaku? Tak ada ejected elektron. Kalau kurang, dia takkan ada elektron yang keluar. Tak kisahlah berapa lama dia pancarkan, kalau memang photon tu initially wavelength dia tak cukup, wavelength dia terpanjang sangat, dia memang takkan ejected sampai bila-bila. Maksudnya energi ni kurang, pada hantar 10 pun, katakan contoh, katakan ini adalah 4 joule untuk satu elektron, satu photon. Energi required adalah 6 joule. Kalau dia hantar 3, so 4 joule, 4 joule, 4 joule, apa yang berlaku? Dia akan interact dengan respective electrons lah. Dia tidak keluar juga. Faham ke tidak?
Faham, sir.
Okay. Sebab apa? Sebab student bila dia jawab soalan, kebanyakan soalan dia tengok macam yang atas, kes atas ni, sentiasa ada elektron keluar. So dia terlupa yang kalau dia sama ataupun kurang, sebenarnya elektron tu kalau sama dia keluar tapi dia tak bergerak, kalau kurang dia tak keluar terus. Okay, we go back to that question number 9. Tapi kat sini dia katalah elektron tu emitted dengan ada kinetic energy. So dia keluar dan dia bergerak. Dia dah cakap. Okay, now you just want to take out the information. So when you take out the information, my suggestion is that you write down information tu dekat respective punya objek. Contohnya kan, macam 500 nanometer tu, adakah itu berkenaan biru, purple ataupun hijau dan 500 nanometer tu. Which tu pasal apa? Kamu rasa biru, purple, hijau? Which one?
Biru
Biru kan? Itu adalah incident light. Jadi incident light tu ada wavelength from 100 nanometer. So basically, I just have to write down over here. Lambda sama dengan 500 times 10 negative 9 meter. Okay. Lepas tu dia kata, electrons emitted maximum kinetic of 0.57 eV. Itu purple ke hijau? Ke biru?
hijau.
Hijau kan? So Kmax sama dengan 0.57 eV. Okay, very good. The first question they want to calculate the work function of the cesium. So obviously you want to apply the Einstein equation. So kalau ingat lagi, E sama dengan W0 tambah Kmax. Okay, kamu dah ada kamu dah ada lambda, tak ada E lagi, tapi kamu boleh carilah E dia. Lepas tu kamu kena tukar Kmax ni kepada volt joule, and then baru kamu boleh cari W0. Okay, cuba kita buat ya. So first step, kita klik E. E sama dengan Hc over lambda. So this is the energy of the incident light. Okay, if you calculate, you get ni sebenarnya sama dengan atas tadi kan, 3.99 3.98 sorry, sebab dia sama wavelength. 3.98 times 10 negative 19 joule. Okay, and then the next step, you have to convert Kmax tu jadi joule. Kmax tu sama dengan 0.57 eV. Kalau kamu nak convert kepada joule, you have to multiply with 1.6 times 10 negative 19. So you get 9.12 times 10 negative 20. So basically, when you try to substitute inside Einstein equation, step 3 E sama dengan W0 tambah Kmax. All the quantities need to be in the same unit yang sama. Kamu boleh tukar E menjadi EV juga. Final answer W0 tu dalam EV. Boleh. Tapi biasanya saya galakkan kamu kira semua dalam joule. Final answer kamu tukar EV kalau soalan perlu lah. Kalau soalan minta, kalau tak biar je. So here 3.98 you substitute over here. Okay, W0 kita nak cari plus 9.12 times 10 negative 20 joule. So W0 basically tolak dia yang nilai tadi 3.07. Okay, so maybe kamu punya jawapan akhir tu lain sedikit daripada jawapan akhir kat tutorial answer tu, doesn't matter. Sebab biasalah bunda tak bunda, macam tu je. Okay, faham ke tidak?
Faham, sir.
Okay, soalan seterusnya yang B pula. Dia kata stopping potential of the electron emission produced from the light ray with a wavelength of 600. Okay, so now dia nak cari stopping potential. Itu dia punya VS. VS tu di dalam E ke dalam W0 ke dalam Kmax? EVS. VS tu daripada mana? Kamu ingat tak Kmax sendiri sama dengan EVS? Okay, good. Okay. Lepas tu dia kasih lambda sama dengan 600 nanometer. 600 nanometer tu duduk kat mana? Biru ke purple? nanometer. Tengok soalan dia. Stopping potential of electron produced from the light ray with a wavelength of 600 nanometer. So 600 nanometer tu adakah biru atau purple?
Biru.
Yes, very good. Okay, so this one adalah 600 times 10, negative 9 meter. This is your lambda for the incident light. So macam biasa, first thing first, you calculate energy of the incident light. E sama dengan HC over lambda. Okay, jangan malas tulis ni sebab apa? Kamu ada markah penggantian. Okay, so if you get the final answer wrong, kalau kamu buat yang betul, at least you still get 1 mark. So you have to be extra careful when you press your calculator. Here I got 3.32 times 10 negative 19 joule. Okay, so after that, yang purple tu sebenarnya dia dah ada nilai tu. Nilai tu dia pakai metal yang sama. So basically itu hanyalah yang W0 tadi tu. W0 sama dengan 3.07 times 10 negative 19. So basically you can apply Einstein equation. E is equals to W0 plus K max. Okay. Tapi E tu kita dah kira, dia jadi 3.32 times 10 negative 19. W0 tu pun dah ada nilai dia, 2.07 times 10 negative 19 plus K max ni yang jadi EVS. Okay. E tu dia ada nilai 1.6 times 10 negative 19 multiply by VS. So your VS should be equals to, I got 0.16 volt.